Good morning, everyone. Nice to meet you. My name is Maria Victoria Cerqueira Barreto, and with my professor Luiz Hernan Contreras Pinochet, Vanessa Itacarambi Pardim from the Faculdade de Economia, Administração, Contabilidade e Atuária of the University of São Paulo, we are going to present our study entitled Synthetic Data, Possibilities, Challenges, and Opportunities, a comparative study of three-generation methods. So, moving on. Many researchers work with small data sets or sensitive information that cannot be easily shared. So, synthetic data has become an important solution because it allows researchers to generate artificial observations based on real data while protecting privacy. However, not all generation methods produce the same quality. Therefore, moving on, this study has three objectives. First, empirically test whether synthetic generation methods can realistically complement a small human dataset. Compare three distinct methods. First, the Weil variational autoencoder, Gaussian copula, the GC, and Wasserstein generative adversarial network with gradient penalty, WGAN-GP. Then, the last but not the least, identify which method most closely resembles human-generated data in statistical, relational, and analytical characteristics. Talking about the methodology, we started with a dataset containing 82 human responses. Each generation method reproduced 328 synthetic observations, resulting in datasets with 410 records. Then we compared the synthetic datasets against the original human data using several statistical evaluation metrics. Then, oh my goodness, come on. So, we evaluated three popular synthetic data generation methods. First, the variational autoencoder, which learns compressed latent representations of the data. Second, the Gaussian copula, a statistical method that preserves marginal distributions and dependencies. Finally, WGAN-GP, an adversarial deep learning model designed to preserve complex multivariate relationships. Instead of evaluating only one statistic, we used multiple complementary metrics. We measured similarities in means, variances, distributions, correlations, multivariate structure, and predictive performance. This comprehensive evaluation allowed us to compare the strengths and weaknesses of each method. So, talking about the results, it revealed important differences among the methods. Gaussian copula achieved the highest overall statistical fidelity. It produced the smallest differences in means distributions and overall similarity compared with the original human data. WGAN-GP, on the other hand, was the best method for preserving multivariate relationships and achieved the strongest downstream analytical utility. They showed the weakest performance across most evaluation criteria. And when we see this graphic, this heat map, we can see that the visual analysis confirmed the numerical results. In the PCA projection, Gaussian copula and WGAN overlap much more closely with the original data. The heat maps also show that the WGAN-GP preserves the correlation structure more accurately, while Weil presents much larger deviations. And talking about the future implications, no single universally superior method, okay? Selection depends on research objectives, so if you want to analyze univariate fidelity versus multivariate structure versus predictive utility, and synthetic data can augment small samples, support simulation-based analysis, and reduce access barriers to sensitive datasets. Rigorous validation procedures are crucial for effective use of synthetic data in scientific research. These are my references. I thank you so much for your watching. I hope you appreciate it. And if you need some doubts, you can contact me. And thank you so much.